Right, so this is the last video in this particular section on trig, although there's a shed load more trigonometry to do later on in the course, but this is the last one on let's say, this particular section, and we're going to have a look at doing proofs with trig and using those trig identities that we saw in previous videos. So, here we go. So we're going to use trig identities to prove trigonometric statements. Off we go. So, okay, we've got two statements there. And so what we've got to do is say that this thing on the left here, sine 2 theta, tan 2 theta, plus cos 2 theta, when we kind of manipulate it, change things around a little bit, and it will all become just 1 over cos 2 theta. So what we're going to do, and in order to approach these in the right way, all we've got to do is kind of just start with what's on the left, completely ignore this bit on the right for now. Okay, have it there in the back of your mind as what you need to work towards, but just take this thing that's on the left-hand side and see if we can manipulate it, change things, and turn it into what's on the right hand side. And the obvious place to start with this one is with the tan 2 theta, because we know that tan 2 theta is sine 2 theta over cos 2 theta, so it seems, being as we've got a sine 2 theta and a cos 2 theta already sitting there, it seems to make sense to replace the tan and see if that helps us out in any way. So there we go. So what we've got now is particularly this term here. We've got sine 2 theta times by the fraction, and this is multiplying on the top, so what we've got here is sine squared 2 theta. So we've got that. Now, essentially what we're doing here is we're adding together two fractions. This thing is a fraction, and this thing here now doesn't look much like a fraction, but we can make it a fraction by creating a new denominator, and that new denominator is going to be cos 2 theta. Because if I've got cos 2 theta on the bottom, that the age-old rule about fractions, in order to be able to add them, you've got to have the same denominator. So if we can write this thing here as a fraction with cos 2 theta on the bottom, then we're going to be able to add these two terms together. So what I'm going to do is times that thing times on the top by cos 2 theta times on the bottom by cos 2 theta, and so cos 2 theta becomes cos squared 2 theta over cos 2 theta. Now I can do the adding together. There we go, so there they are written as a single fraction, and hopefully you can now spot what's going to happen. We can see that the top here, cos squared plus sine squared, we know cos squared plus sine squared equals 1, and so there we go, that's the result that we were aiming for. So we've proved that sine 2 theta, tan 2 theta plus cos 2 theta actually turns out to be much more simply 1 over cos 2 theta. Right, so on we go. So we've done the first one. Let's have a look at the second one, which is 2 sine squared theta minus 1 over sine theta plus cos theta is the same as sine theta minus cos theta. So again, we're going to start with the left hand side and manipulate it and turn it into that thing on the right hand side. So the obvious place to start with this one is say, well, if I've got a sine squared theta, we can replace that and use sine squared plus cos squared, sine squared theta plus cos squared theta equals 1, and replace the sine squared with a 1 minus cos squared. Okay, multiply out the brackets, we've got that, and now we've got 1 minus 2 cos squared theta over sine theta plus cos theta. And at this point, I'm starting to think to myself, well, really, have I achieved anything there? And the answer to that is genuinely, we haven't really done a whole lot. All we seem to have done is swap the sign for a cos, reverse them, but we've not really made any particular progress in terms of the form that's in. And so the reason I've put this one in is just to illustrate the fact that sometimes you might try something might look like an obvious route to be able to solve the problem, but sometimes things don't quite work out and we might need to have a think about doing it slightly a different way. So let's bin that off and have another go. And there's a real sneaky trick in here, because what I'm going to do, rather than in that numerator manipulating the sine squared, what I'm going to do is focus on that 1 there. And we know that 1 is sine squared plus cos squared. So what I'm going to do is replace the 1 with sine squared theta plus cos squared theta and see what that gives me. Well, what it gives me is sine squared theta minus cos squared theta on the top and sine theta plus cos theta on the bottom. And again, here comes the next real sneaky trick, because if you're sharp and you're clued in, you'll realise that what we've got in the numerator here is dots, difference of 2 squareds. Yeah, so for example, x squared minus 9 would be x minus 3x plus 3. In exactly the same way, sine squared theta minus cos squared theta actually can be factorised, and you've got sine theta plus cos theta times by sine theta minus cos theta. And again, you might just want to pause the video and just convince yourself that when you multiply that back out, you do end up back at sine squared minus cos squared. The reason that's really useful is you'll now notice that we've got sine theta plus cos theta on the top, sine theta plus cos theta on the bottom, and a bit of cancelling leaves us with the result that we're after. Now I start this example by saying, okay, the obvious thing to do is replace the sine squared with 1 minus cos squared, but I've got to be honest, kind of the more experience you get, the more of things like this that you do, the more you realise that for me, I'm seeing this term here, I'm seeing that term, and those two things there are the two factors from difference of 2 squares, sine squared plus cos squared, sorry, minus cos squared. So that kind of alerts me to the fact that, you know what, kind of difference of 2 squares might be a useful one to use. And I've got to be honest with you, if you've got a sine theta plus cos theta, there's not a whole lot you can do to manipulate that. So there had to be some kind of trick with the top, and it was linked to those two things there being factor of difference of 2 squares. So I included that one just because, like I say, it was a bit of a tricky one, and it wasn't an obvious spot to take out the one and replace it, but that would have been the way to do it.